Yes, sir.
Couldn't you just do the derivative? I mean, like the integral of the outers and just leaves.
Okay, as long as it's written beautifully like this, yes. That's not going to last. I mean, I'm literally setting it up so it, oh, look, it magically matches every time.
Can I look at my calculator?
Magically match, I don't know where it is. That's what I just said. Ella, I don't know where it is. I'll look for it in just a second. Let me do this problem. So I got the integral of 5x plus 1 squared 10x dx. All right, so I set you to the ugly part. I would assume you guess 5x plus 1. By the way, if you get it wrong, all that happens to you is you do what? Start over and you go, that didn't work. Let's try something different. So then, whoops. What did I do wrong here?
It's 5x squared.
Oh, it's 5x squared. Let's say something bad happened on the way to that problem. That problem's not going to work. Here's an example of one not working. Okay, so then I got 10x dx. So du equals 10x dx, right? Du. So then I look, I try to make sure it matches. I see I already have the match in place. So I can rewrite this as the integral of u squared du. There, u squared is 1/3 u to the third plus c. Put it back in. I got 5x squared plus 1 to the third power plus c.
That's what I got.
There you go.
Too.
All right. Everybody try the last one.
I don't know.
I'll throw a slight curve at you. Got a little bit of work. The next one's gonna get some interesting things on it. It's got the beginning of problems.
Go.
All right, I've got this. I got x. I got x squared plus 1 squared dx. Sierra,
Yes.
what is the ugly part?
X squared plus 1.
X squared plus 1. So the derivative would be du dx is equal to 2x. We write that as du equals 2x dx, right?
Yeah.
So I'm feeling really good. I rewrite this as the integral x squared plus 1 squared x dx. What am I missing?
2.
We need to put a 2 there. Has to be a 2 there. Now it's a multiplied constant, correct?
Yes.
So what if I did the following? What if I went ahead and put a 2 here? But that's changing it.
Yeah.
So in order to not change it, I also have to multiply by half, which I'll put out here. Because it's a constant, it doesn't matter, right? Could I do that with an x? No, because an integrated x is different than a non-integrated x. But integrated half and a 2, not different, right? So I can change the constant by multiplying by its reciprocal outside with the constant inside. Make sense? Outside the integral. Now again, it can be inside too. It doesn't change it. It'd be 1/2 u squared. That's okay too. I tend to just pull it all the way out just to give me one less thing to look at.
But where? So did you just move the x from the front? Like where?
I moved it so that I'm trying to make this look like this. So then I can rewrite in terms of u.
Okay.
So this becomes 1/2 the integral u squared du, right? And what's the integral of u squared?
1/3.
That 1/2 times 1/3 u to the third plus c.
So 1/6 u.
Oh. I'm going to replace the u. Is that okay? So that'd be x squared plus 1 to the third power plus c.
What happens if there's a different x though?
If there's a different x, you pretty much can't use this method.
And what method would you use?
We're going to come up with another method.
How are we going to do that?
You're going to learn 2 more ways to do integrals beyond this. And then there's a whole bunch of ones, random ones I'm going to make you memorize. And then we're pretty much done with integrals.
What are we doing right now?
We have 15 weeks of school left.
What are we going to do for the next 15 weeks?
The calculator's at-
Trust me, you won't be sad about the amount of things that are coming in front of you. Because we haven't started to talk about,
There's very few things in
we remember how in the first semester we did related rates, and then we did maximizing, minimizing functions, you know, stuff you can figure out some sort of value, and something that had some sort of realistic sort of values. We haven't done anything with integrals yet, except for how many cans are on the floor. It's coming.
Well, how many kids are on the floor spot?
Yeah. We're going to, if you want, since you asked for it, the next few chapters are going to be, the chapter after this, we're almost done with this chapter, by the way. Okay. Chapter this one I call the library chapter, and the reason why I call it the library is because I'm going to teach you how to do integrals of log naturals, e to the whatevers, on and on it goes, all the little random ones we haven't gotten to yet.
Oh, is that
So we
the
just have to
integrals?
memorize?
You just have to memorize the derivative and then know the what? Oh yeah, my bad. And then the chapter after that, we're going to do volumes of weird shapes. We're going to find how much volume, how big a volume something strangely shaped is. Now we're going to be able to integrate that by doing the area. And then last but not least, we do the calculator test, which is horrifyingly easy, and yet somebody else still get a 33 on it, just to make fun of me.
Is that the last one we're gonna take?
And that's the last one. Then we study for your AP calculus test. We get done with that, and then we've got 2 mini tests after that where I try to get you ready for next semester, because some of you, what you earn by doing this is you get to skip the first quarter or semester of calculus, and if you do that, the second quarter is the nasty part anyway. So
If we know we're not gonna pass it, can we just?
I'm gonna fail the entrance exam.
no, I'm gonna make everybody do it simply because there are several students that told me they'll never use. They swear to me they would never use it, and yet they're